You're welcome to the Scholar School. We establish our footprints on the sand of time, experience the difference.
You're welcome to the Scholar online class. My name is Abdulwasiu. I'll be your mathematics tutor. And the topic we'll be treating this today is quadrants and the nitty-gritty of quadrants. So what we'll be looking at in this topic, we'll look at the definition of quadrants, properties of quadrants, problems on quadrants, special angles derived from the graph, then other related problems on quadrants. Now, from our basic knowledge, when we talk about quadrants, a quadrant is a quarter of a circle. If I draw a circle this way, this is one circle. Divide it into two. This is half, this is half. Then when you divide it further, this is quarter, 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 quarter. So when you take a quarter of a circle, that refers to what? A quadrant. So that is the definition of a quadrant. Now, in our quadrant, from that definition, basically we have four quadrants. Starting from this side in the anti-clockwise direction. This is first quadrant. This is second quadrant. This is third quadrant. And this is fourth quadrant. So based on these four quadrants, then we can narrow it down to this: A, S, T, C. And I'm going to show you how we arrive at this A, S, T, C. So all these A stand for what? Stand for a particular narrations. A here means what? All of them are, all these three signs are, the three angles are equal, are positive. S here stand for sine, T here stand for tangent, and C here stand for cosine. Now, for each of the quadrant, if you take it from the form of rotation, this is 0 degrees. This is 90 degrees. 90 plus 90, this is 180 degrees. 180 plus 90, this is 270 degrees. And back towards 360 degrees. That gives us a complete rotation. Now, starting with the first one, first quadrant. First quadrant. So for our first quadrant, we have what we call the range. Meaning it ranges between, you can see from what I have here, 0 to 90. So we say 0 degrees is less than theta, and theta is less than 90 degrees, where theta is the angle between the two. So we have this for first quadrant, 0 degrees to 90 degrees. So we have a line here drawn, and this is the angle between that. So from what we have here, this is 0 degrees. So let me label this as O and line P. Then let's say this is Q. So from this right angle triangle that we have here, then we are going to look at the three ratios using our SOHCAHTOA. So sine opposite hypotenuse, adjacent and TOA opposite over adjacent. So I'm going to take the ratio of sine and cosine and tangent. So from what we have here, this is OP, this is OP, and then OP and OQ. And from our sign conventions, just like we know that before, if you are moving upward, it is positive. If you are moving to the right, it's also positive. If you are moving to the left, it's negative. If you are moving downward, it's also negative. So we are going to put these sign conventions into consideration. Mind you, this hypotenuse here is always, we take it as always what? Positive. And it's always what? Unity, which is 1. So from what I have here, if this is my y and this is my x based on the axis, then I have sine theta equals to what? Opposite, that is PQ all over hypotenuse OP, which gives us plus, sorry, this is y, which equals plus y over plus x. Since they are on the same quadrant, And plus divided by plus will give us what? Positive. That is for sine. Now for cosine, cos theta, adjacent over hypotenuse, that is OQ over OP. By definition, which is what? Plus x divided by plus the hypotenuse is, I say is always what? 1. Sorry, this is 1. So plus divided by plus will give us what? Also what? Positive here. Then the third one, I have tan theta. That's opposite over adjacent. That is PQ divided by OQ, which is equals to plus y over plus x. Plus divided by plus will give us what? Positive. So the summary from what we have here, the summary is that in the first quadrant, all the ratios, are positive. And what ratio are we talking about here? That is your sine, your cosine, and your tangent. So that is how we arrive at the letter A, which word represent the word all for first quadrant. Now let's move to the second quadrant. So, but for first, before we leave the first quadrant, the formula here, we just have two basic formula here. The first formula is that sine theta is equals to plus cos 90 degrees minus theta. Y cos theta is equals to plus sine 90 degrees minus theta. We call this one complementary angles. Complementary angles. So let's move to second quadrant. So for second quadrant, look at the range here, 90 degrees to 180 degrees. Just as usual, this is my y-axis, this is my x-axis. Now the angle is moving from here down to this place now. So we have this as our theta. And this is the angle we are looking for. So still completing this side this way to form a right angle triangle. Mind you, this side will be what? Negative. Why this one, since it's still upward, will be positive. So still using our x and y as reference points. This is my y, this is my x. So we are taking the three ratios. So the range first. Our range is that 90 degrees is less than theta, and theta is less than 180 degrees. So now what is now the ratio? So our ratio is that sine theta is equal to opposite. This is still my P and this is my Q. Opposite over hypotenuse, which is what? Plus y over plus 1. Remember I said the hypotenuse is always taken as 1. So, and that will give us what? Positive. Then for cos theta, I have adjacent over hypotenuse. That is my OQ over OP, which is equals to minus x over plus 1. Negative divided by positive give us what? Negative. Then for tan theta is equals to opposite over adjacent. That is PQ out over OQ. Our PQ is plus y. Our OQ is what? Minus x. Positive divided by negative give us negative. So the summary from what you have here is that in third quadrant, only what here now is positive. Only what? Sine. Only sine is positive. And when you say only sine is positive, meaning the other two are what? Negative. Meaning cosine is negative and tangent is negative. That is how we arrive at the word letter X. S for the second side of the quadrant that we have on the board. So the formula for second quadrant here, our formula For second quadrant, we have sine theta is equals to plus sine into 180 degrees minus theta, cos theta is equals to minus cos into 180 degrees minus theta, and tan theta is equals to minus tan into 180 degrees minus theta. So let's take example based on the first and second quadrant before we move to the third quadrant. Example 1. Example 1. Given that cos theta plus cos theta is equals to sine 2 theta. I'm going to find the value of theta. Given that cos theta is equals to sine 2 theta, we have to find the values of theta. Now, how do we go about the solution? We have cos theta is equals to sine 2 theta, right? So what you do is what? You try to make sure that the two ratios that you have on both sides are of the same order. What that means that if this is cosine, this also must be cosine. Or if this is sine, this also must be sine. So how do we achieve that? Use our first quadrant. What's the formula for first quadrant, which is our complementary angle? Recall that sine theta is equals to cos 90 degrees minus theta, or cos theta is equals to sine 90 degrees minus theta. So I can use any one of the ratio. Now, assuming I want to use cosine now, I'm using the second formula as the yardstick here. I say cos theta is equals to sine 90 minus theta. It means that anywhere I see cos theta in this expression, I replace it with what? Sine 90 minus theta. So that means from this expression, it means that sine 90 minus theta is equals to sine 2 theta. You can see that both of them are what? Of the same order. So the sine will cancel out the sine. Let me say I now have what? 90 degrees minus theta is equals to 2 theta. Collect like terms. 90 degrees is equals to 2 theta plus theta. 90 degrees is equals to 3 theta. Divide both sides by 3. 90 degrees over 3 is equals to 3 theta over 3. Therefore, our theta is equals to what? 30 degrees. That's it. Okay, let's move on. Example 2. Example 2. Evaluate the following angles. The first one, I have 135 degrees. I have 120 degrees. I have 180 degrees. So let's stop on these 3. Now, if you look at this, the essence of this is the what? We don't have calculator, you don't have 4-figure table, and you have to evaluate this angle. So, and you know that even if you have a 4-figure table, this angle is above what you have in your 4-figure table. Your 4-figure does not exceed 99. So, but here you have 135, 120, and 180. So all this is what they are what? They are obtuse angle, which is greater than 90. So how do you achieve this? That is where the issue of quadrant comes into play. So we are going to use quadrants, which is second quadrant. So solution. So since all the angles are greater than, since all the angles are greater than 90 degrees, but less than 180 degrees. So it means that they are all in what? In second quadrant. So based on the rate of our second quadrant, we have 90 degrees less than theta, theta less than 180 degrees. So that is where the application of this come into play. So we have to evaluate 135, 120, and 130. Let's use only sine and cosine as our case study here. Sine theta, then cos theta. So the first one I have sine 135 degrees. So I'll go back to my quadrant. My theta is 135. What is the formula? So my theta is, so if our theta is 135, so therefore sine 135 degrees is equals to plus sine into 180 degrees minus 135 degrees. And that gives me sine 80 35. This is 5. 7 minus 3, that is 4. That gives us sine 45 degrees. So that is the equivalent. And our sine 45, based on our previous knowledge, which I will still revise that, is 1 over square root of 2, or 0.7071. Then similarly, if I'm to take the cosine of that angle, cos 135 degree, the same thing as what? Minus cos into 180 degrees minus 135 degrees, which give me minus cos 45 degrees. And our cos 45 is also the same as minus 1 over root 2, or minus 0.7071. Now let me take one more, 120 now. We're looking at sine 120 degrees. Sine 120 degrees. Still following the same procedure. Our theta is 120 degrees. So therefore, my sine 120 degrees is equals to plus sine into 180 degrees minus 120 degrees. That gives me plus sine 60 degrees. And based on our trig ratio, sine 60 degree is something as plus the square root of 3 over 2, or 0.8660. Then similarly, cos 120 degrees, that is equal to minus cos into 180 degrees minus 120 degrees, which gives us minus cos 60 degrees, and that is equal to minus 1 over 2, or minus 0.5. Then for 180 degrees, this is the second one, and the third one, I have sine, that's my theta 9 is what? 180 degrees. So I have sine 180 degrees is equal to plus sine 180 degrees minus 180 degrees. And that gives me plus sine 0 degrees. So based on our previous knowledge, sine 0 is still 0. Likewise, cos 180 degrees is equal to minus cos into 180 degrees minus 180 degrees. And that gives us minus cos 0 degrees. Cos 0 is 1, so this will give me minus 1. So these examples are based on the first and the second quadrant. Let's now move to the third quadrant. So for our third quadrant, we have the range as so, as into third quadrant. The range, we have 180 degrees less than theta, theta less than 270 degrees. How do I achieve that? It's based on this. This is first, second, third. So we are now here now. So it means that the line our unit line will now be at this side. Our angle will fall in that range. So this is for third quadrant. Starting from here, my theta will now fall here. So this is my theta, which is obtuse, which is what reflex angle, greater than 180 but less than. So this is our angle of reference. This is our angle of reference. So this is still my y, which is negative. Based on my initial explanation, this is negative. Then this one is also pointing to the negative direction. This is also negative. This is the right angle. This is our angle that we're looking for. So if this is still my y and this is still my x, then I'll have, let's say this is OP. Here our P is unit and this is Q. So I have sine theta is equals to opposite over hypotenuse. That's minus, okay, let's say PQ over OP, which is equals to minus x over plus 1. Remember I said the hypotenuse is always taken as 1. And that gives us what? Minus, will give us negative. Then cos theta adjacent over hypotenuse. That is OQ all over what? OP, right? So, and that gives us our OQ is what? Minus y over plus 1. Negative by positive give us negative. Then our tan theta is equals to opposite over, that is PQ over OQ. This is equals to minus x over minus y. Negative by negative give us what? Positive. So the summary for third quadrant is that in third quadrant, only tangent is positive. So meaning the other two, our sine and cosine are negative. That is why we have the letter T, which stands for what? Tangent for the third quadrant. So what's the formula here? Our formula is that for third quadrant we have two formulas. I'll state the two side by side. The first formula is that sine theta is equals to, since sine is negative, that's minus sine into theta minus 180 degrees. Then cos theta is equals to minus cos theta minus 180 degrees, and tan theta is equals to minus tan into theta minus 180 degrees. This is the first formula. The second formula is this. Sine is the second formula, but we use them in different scenarios. We don't use them in the same state. So sine theta is equals to minus sine into theta plus 180. Cos theta is equals to minus cos into theta plus 180, and tan theta is equals to minus tan into theta plus 180. So you can see, as you can see on the board, the first one is negative, while the other one is what? Addition. So, but we have different application of the two. So let's take the fourth quadrant and we'll now take the problems on the two. So for our fourth quadrant, so the range, we have 270 to 360. So we have 270 degrees is less than theta and theta is less than 360 degrees. So it means our rotation is complete now. From the beginning here, moving down up to this side. So this is my theta, while my angle of reference is this one here. So the rotation is now back to the what? To the positive arena. So this is my P, this is my O, this is my Q. So just like we did in the other one, this is positive, Then you are moving downward, this will be negative. The line is moving downward. So we still maintain this place as our y and this as my x. So taking the three ratios, then I have sine theta is equals to opposites, that's PQ over hypotenuse OP, which is equals to PQ is what? Minus y over OP is what? Plus 1. That gives us negative. Positive by negative by positive. Then cos theta is equals to adjacent OQ over hypotenuse OP, which is equals to plus x over plus 1. Positive by positive give us what? Positive. Then I have tan theta is equals to opposite over adjacent. That is PQ over OQ, which is equals to minus y over plus x, which will give us negative. So the summary is that in fourth quadrant, now fourth quadrant, only cosine is positive. Is positive. And that is why we have the letter C as represented on the board. So the formula for fourth quadrant, we have sine theta is equals to minus sine into 360 degrees minus theta. Cos theta is equals to plus cos into 360 degrees minus theta, and tan theta is equals to minus tan into 360 degrees minus theta. So let's summarize what we mean by quadrants. And from what we have there, from the abbreviation we have there, then we take it as, if you take it from here, from the fourth quadrant here, then bringing the words together, you can have it as the acronym that what? Casts. As cast, that's cosine, cosine, all of them are positive, sine only, and tangent only. Or taking it from what? From the other angle, we can have it also as what? As arcs. That is ACTS in the other direction. Or preferably, if you are taking it in your own way, you can frame it out as what? All students take Coke or any other drink. So where A stand for the all, S stand for, and T stand, why C stand for the. So that is the how to remember those quadrants easily. So let's now look at examples on third and fourth quadrants. Example 3. Determine the quadrants in which the following angles lie. The first one, 060 degrees. Number 2, 305 degrees. Number 3, 475 degrees. Number 4, 1008 degrees. Number 5, 200 degrees. So let's just limit out at this 5. Now, solution. So the first one, I have 0 degrees, so our theta is equal to 060 degrees. We think that's what? 60 degrees. So if you look at the quadrant, 60 degrees is less than 90, but it's greater than 0. So automatically it will fall in what? In our first quadrant, based on the range of 0 to 90. So therefore, this is what we have here. 60 degrees. So it what? Lies in first quadrant. Okay, second one, 305 degrees. Go back to your rate, 0, 90, 180, 270, and 360 degrees. So if you look at it, 305 is bigger than 270, but it's less than 360. So automatically, it will fall in what? Fourth quadrant. So this is what you have here for your 305. In the anti-clockwise direction, 90, 90, 90. This is 90 plus 90, that's 270 plus 90, that's 3, 90, 180, 270. Then what is going to complete to give us 305? So this 305 minus 270, this is 5, this is 3, that's 35. So additional 35 degrees. This is 35. So this is my 305. So which lies in what? In fourth quadrant. So therefore, 305 degrees lies in fourth quadrant. Then the next one, 475. Now 475 has what? Has exceed the limit. 475 degrees. This is above 305. And if you recall from our previous lessons, we did something like angle, negative angle, and angle greater than 360 degrees. So anytime you have an angle that is greater than 360 degrees, in order to get the angle equivalent to that, you subtract 360 from such angle. So this minus 475 is equivalent to 475 minus 360 degrees. This is 511. So this, which is equivalent to 115 degrees. Now, if you use any calculator, you can confirm this, that this is equivalent to this. And my 115 can also be converted to the what? To the acute angle. So further still, my 115 can also be 180 minus 115, which will give me the acute angle equivalent. But that's not what we are asked to do. So we are just asked to locate the quadrant in which this lies. So since this is less than 360 degrees, then 115 is greater than 90, but it's less than 180. So automatically it will lie what? In second quadrant. So therefore, this is what we are going to have for 115. This is my 115 degrees. 90 plus 25 or so. So this is my 115 degrees. So it's what? This is where it lies. So therefore our 475 lies in second quadrant. Then the last one, 1000, okay, 1008. Still the same thing with this. You subtract until you get angle that lies between 0 and 360 degrees. So for that, we have 1000 and number 4, 1008. So this is equivalent to 1008 minus 360. 360. 8. This give me 4. This give me 6. This is equivalent to 648. 6 is still greater than 360. Subtract again 360 from it. 648 minus 360 again. 360. 8. 40 minus 6 8. Then this is 2. So this is equivalent to what? 288, which is less than 360. So if you go back to your quadrant, this is greater than 180 and it's also greater than 270. So automatically it will fall in what? The fourth quadrant. So therefore, my 1008 degrees, which is equivalent to 288, lies in fourth quadrant. Okay, I hope that is taken. Now let's go to example 4. Example 4. Example 4. Find the values of theta lying Okay, find the values of theta with the range 0 degrees less than theta, theta less than, let's start with 270 degrees for the following. Okay, so let's look at the following. The first one, I have sine theta is equals to 0.7071. Number 2, cos theta is equals to minus 3/4. And number 3, tan theta is equals to minus 7/5. Okay, solution. Now the first one. So here I'm going to combine two things. Let me use the case of, let's say, 0 degrees less than theta, theta less than 180. That's the first one. Then I'm going to solve for 0 degrees less than theta, theta less than 180. It's 270. And I'm also going to look at 0 degrees less than theta and theta less than 360 degrees in order to wrap everything up as we go. So the first one, I have sine theta is equal to 0.7071. What you do first is to get your theta. This is the, so you get the inverse of that angle. So our theta is equals to arc sine 0.7071, which we normally write as sine inverse 0.7071. And this will give me 45 degrees. That's my value of theta. Now we have to find what is the range now. Starting with the first one. We are taking our theta as what? The range here now. Theta range between 0 and what? And 180 degrees. That's the first scenario we are looking at. Now if you go back to your quadrants, because that's what we're referring to all the time, ASTC. 0 degrees, 90, 180, 270, and 360 degrees. So for the first one, since our value here is positive, what you have as value is positive, then sine theta, where is sine theta positive? Between 0 and 180, that's what we look at in the quadrant. So sine theta is positive both in the first and second quadrant. So that means you are going to have two answers. The first answer is for the first quadrant, which is your 45 degrees. The second answer is for what? Second quadrant, which when you apply the formula now, you subtract this from 180. So therefore, our theta is positive. But let's put it this way. My sine theta is positive in the first and second quadrant, respectively. So which means that for the first quadrant, my theta is going to be what? 45 degrees, which is what I got here. While for my second quadrant, my theta is going to be what? 180 minus 45, which will give us what? 135 degrees. So this will be your two answers. So you are not going to get only one answer. Now that is for between 0 and 180. Now let's now take between 0 and 270 degrees. The range now. Between 0 degrees and theta less than 270 degrees. You are still doing the same thing here. You still go back to the quadrants. Now you are covering three portions now. 1, 2, 3. For 180 is just two portions. So for 270 now you are extending it to the third quadrant. So you still go back to, since you are dealing with sine, and your sine here, the value given to you is what? Positive. So if you go between 0 to 270, where is sine positive? It's still what? First and second. So you don't have any business with this third one. So your answer will still remain what? Our theta is positive in only first and second quadrant. All that is taken. Then the last one, which is for what? 0 degrees less than theta, theta less than 360 degrees. Now you are now taking the complete rotation. So still go back to it, you are still going to have the same answer. Sine is positive only in what? First and second. So your answer still remain 45 and 135 degrees. How that is taken. Let's now take that of the second example, which is cos theta is equals to minus 3 over 4. Cos theta is equals to minus 3 over 4. So the first thing is to change this one to decimal. So our concept will give us 0.7500. And we need to take the inverse of this. Now, in taking the inverse of this, you are not going to make use of the negative sign. You are not going to make use of the negative sign at all. So the negative sign is, the essence of the negative sign is for you to determine which quadrant that value will lie. That is the essence of that. So I have theta is equals to r cos 0.7500. And that gives us, so from our sinusoidal graph, which also called sine graph, we have this. This is my y. So this maximum here is +1, and this minimum here is -1. This is half of a circle, this is also half of a circle, giving us what? A complete circle. That's a complete rotation. So this is the origin, starting point. This is 0. This is getting to its peak at 90 degrees. This is half of a circle. This will be 180 degrees. This will be 270 degrees. This will be 360 degrees. Then in between, this will be 0.5, half of it, minus 0.5, half of it. And likewise, I have this here. So we are going to look at the angles 0 degrees, 30 degrees, 90, 180, 270, and 360 degrees. This is only for sine. So from what you have here, sine 0, from what you are seeing on the graph, look at it here. At 0, remember this is my y and this is my x. So at 0, has anything happened there? Of course not. So that is why sine 0 still remains 0 degrees. That's why sine 0 still remains 0 degrees. So let's go to the next one. Sine 30 degrees. Now, our 30 degrees, that is the angle of what? Projection. So remember that if you take this in range, 30 in 3 places will give us 90. Am I correct? Yeah. So this will be, let's say this is 30, this is 60, this is 90. So look at where my 30 lies. Then take it to this side of the axis. I hope you can see that. Then look at my 60 if I take it further. Then take it to this axis and look at my 90 degrees. So from what I have here, sine 30 will give us what? Equivalent to what? 0.5. 0.5. Then for 60, as you can see here, that is 0.7 something or 0.8, closer to 1. So sine 90 degrees. Let's just go to sine 90 is what? Plus 1.0. Then 180 is on what? On a still on the horizontal line. It has not moved anywhere. So sine 180 is still what? 0 degrees. 270. Sine 270 degrees, look at it here, peak at what? Minus 1.0. Then sine 360 degrees is equals to what? 0 degrees. So in summary, it means that sine 0 degrees is equivalent to sine 180 degrees is equivalent to what? Sine 360 degrees. That was the first thing. Then secondly, sine 90 degrees is equals to negative sine 270 degrees from what we have here. And that summarizes everything on that, which is a special angle. So we have also for cosine. Next time we'll take that. Then other related problems on quadrant, just like what I explained earlier, is that 41.41 degrees, 41.09 degrees. So approximately 41.4. Let's do it with one decimal place. Now back to the basis. This is our value of theta. Mind you, remember that our angle given here is negative. I remember that I say you're not going to use it. The essence of the negative for you to determine the quadrant where the angle lies. So now going back to what we have here, our ratio, starting with 0 degrees and 90. So the first case we are taking is when theta 0 is less than theta and theta is less than 180 degrees. Where will this value lie? Remember it's negative. So you now go to the quadrant. Where is cosine negative? That is what will be your answer. So this 41.4 is not part of the answer. Why? Because what is given to us is negative. The answer we have is what? Is for the positive angle, not for the negative. So going back to the quadrant, between 0 and 180 degrees, where is cosine negative? Only in the second quadrant. Because here it means all of them are positive. So cosine is between 0 and 180 degrees. Cosine is only negative in what? In second quadrant. So which means that our cos theta is negative only in second quadrant. That is, our theta will not be what? 180 degrees minus the 41.4. And that gives me 6, then 36.6 degrees. That will be the value. So this is your answer. Here you have only one answer. Why? Because between 0 and 180, cosine is only negative in what? In the second quadrant. Now let's take the second one. This is between 0 and 270 degrees. Number 2. Theta 0 is less than theta is less than 270 degrees. So you still go back to the quadrant. Where is cosine negative? Now you are accommodating the third quadrant now. 1, 2, 3. So cosine is negative in where? Both in second and third quadrant. So here you are going to have two answers. Our cosine is negative in the second and third quadrant. So we have it as our cos theta is negative in both second and third quadrant. So that is our theta in second quadrant. The value of theta in second quadrant is going to be what? 180 degrees minus 41.4, which gives us 136. Sorry, 136.6 degrees. Six. 138. So that gives us 138.6 degrees. So that's the first value here. Then also our theta is what now? Our theta is negative in what? Third quadrant. So the value of theta in third quadrant is going to be what? That is where you now add 180 plus theta, or theta plus 180. So this is where the formula for addition comes into play instead of what? Subtraction. You are adding it to the angle instead of subtracting. So this is going to give us 41.4 plus 180 degrees. And that will give me 221 degrees. 221.4 degrees. So that is where the application of that addition come into play. Likewise, if you are taking between 0 and 360 degrees, you are accommodating all the quadrants. And in this case, your cosa will only be negative still in the second and third quadrant. So this is all about the definition and the properties of quadrant, and we also try to take some problem on quadrants. So let's now move to the next step, which is what? Special angles derived from that, and then other related problems on quadrants. So other related problems on quadrants. Is that when you are given a particular value and you are asked to find or to solve a problem without using tables or calculator, that is where we have that come into play. Now, for example, without the use of table or calculator, evaluate 1 sine square theta minus cos theta over tan square theta minus 1. Cosec square theta plus cos theta over cosec sec square theta sec square theta minus cot theta. Example 2. Given that sin theta is equal to 3 over 5, evaluate 1 cot theta minus sec theta and sin square theta minus cos square theta over sec theta. If theta is acute angle and if theta is obtuse. Okay, let's look at this example. 30 degrees and 45 degrees. So, solution to the first one. I have sine squared theta, sine squared 60 degrees minus cos 30 divided by tan squared 45 plus 1. So, just like I derived earlier, the interpretation of this one is this: sine 60 all squared minus cos 30 divided by tan 45 all squared plus 1. So substituting now. Sine 60 is square root of 3 over 2 all squared. You can refer back to our previous lesson for this one. Now we have arrived at root 3 over 2 minus cos 30. That's also root 3 over 2 divided by tan square 45. Tan 45 is 1 squared plus 1. So this will give me, when you square a root, this is root 3 times root 3 divided by 2 times 2 minus root 3 over 2 out over 1 squared is 1 plus 1. That gives me root 3 will give us root 9 over 4 minus root 3 over 2 out over 2. Square root of 9 is 3 over 4 minus root 3 over 2 divided by 2, which will give me 3 over 4 minus root 3 over 2 times 1 over 2. And finally, I'm going to add either 1 over 2 into 3 over 4 minus root 3 over 2. And leave it like this, or 3 over 2 times 4, 8, minus root 3 over 2 times 2, 4. That's the solution for the first one. Now for the second one, here they say given that sin theta is 3 over 5, evaluate cot theta minus sec theta over tan theta plus 1. In this case, we have two methods, but I think I'll just follow one way. So the easiest way is to draw your triangle. Draw your right angle triangle. This is, let's say this is A, B, C, and let's say this is your theta. Now, using your SOHCAHTOA, they are given sin theta as what? 3 over 5. That is opposites over hypotenuse. So you are looking for the third side. So using Pythagoras theorem, by Pythagoras theorem, the square of the hypotenuse, AC squared, is equal to the sum of the squares of the other two sides, BC squared plus AB squared. So that is 5 squared is equal to 3 squared plus AB squared. So I'm looking for AB. So that means 5 squared minus 3 squared is equal to AB squared. That's 25 minus 9. 25 minus 9 is equal to AB squared. So therefore, AB is equal to square root of 25 minus 9 should give us 16. And AB is equal to square root of 16 is 4. So that means I've solved the triangle completely. So using our SOHCAHTOA, so therefore my cos theta will now be adjacent. This is now 4 over hypotenuse, which is what, 5. And my tan theta is equals to opposite over adjacent, that is what? 3 over 4. Mind you, our sin theta is given as what? 3 over 5. So we solved the triangle completely. So with that now, you can now evaluate what they asked us to evaluate here. So going back to the problem, so they say we should do cot theta over cot theta minus sec theta divided by tan theta plus 1. Recall quickly that cot theta is the inverse of tan theta, which is what? Cos theta over sin theta. Likewise, sec theta is equal to 1 over cos theta, and cosec theta is equal to 1 over sin theta. So with that at the back of your mind, then my cos theta will be what? 1 over tan theta minus sec theta is 1 over cos theta divided by tan theta plus 1. So we can now substitute. That is, this is equal to tan theta is what? 3 over 4. B over 4 minus 1 over cos theta is what? 4 over 5. 4 over 5 divided by tan theta again, 3 over 4 plus 1. So if you look, use the law of reciprocal. When you have 1 over this, the denominator automatically go up. So this will give me 4 over 3 minus 5 over 4 divided by, add this one. This is one whole number, 3 over 4 by addition. 1 plus 3 over 4 give us 1 whole number 3 over 4. So taking this further, this will give me 4 over 3 minus 5 over 4. I'll take the LCM divided by 4 times 1, 4, plus 3, that is 7 over 4. So the LCM of these two is 12. 3 in 4, that is 4. 4 times 4 is 16 minus 4 in 12, that is 3 times 5, 15, divided by 7 over 4. So that will give me 1 over 12 times, when you change this division sign to multiplication, this 4 will go up, 4 over 7. And finally, 4 here, 1 in 12 give us 3. That's 1 over 3 times 1 over 7. So our answer will be 1 over 21. Now, quickly to the second one, or the last one. Sin square theta minus cos square theta divided by sec theta. So let's substitute. So I say sin square theta is known as sin theta, everything squared, minus cos theta, everything squared. Sec theta is 1 over cos theta. So that gives me sin theta is what? 3 over 5. Minus cos theta is what? Cos theta 4 over 5 divided by cos theta 1 over 4 over 5. So this will give me 3 square is 9 over 5 square 25 minus 4 square 16 over 25 divided by law of reciprocal. This 5 will come up, so that's 5 over 4. So taking this further, since the LCM are the same here, just subtract. That will be 9 minus 16 over 25 divided by 5 over 4. 9 minus 16 will give us minus 7 over 25 times 4 over 5. 7 times 4 is minus 28 over 125. And that will be the answer. So that will be the end of the class. So thank you and wish you happy listening.